you. This is from Freakout to Fix, Navigating a Security Disaster. In the next 40 minutes, I want to take you on a short and sharp journey from the moment you realize something went wrong and is possibly catastrophically broken, through the messy middle and out the other side with your integrity and also your users' trust intact. This talk is for everyone who's ever shipped a library, a dependency, or a service that other people rely on, and at some point thought, what if I ship a bug that, breaks the world? You're not alone, and more importantly, you don't have to hide when things go wrong. Let's go from panic to patch, and maybe even feel a little pride in how we handle it. Before we dive into the chaos, let me introduce Tablix. Tablix is a completely fictional Phoenix component, and it powers a data table whose entire state, so sorting, filtering, and even pagination, is encoded right into the URL. With every click you do in this component, the URL updates to reflect exactly what you're looking at. There's no server-side sessions or anything. The URL is just a single source of truth, which is quite neat because you can share these URLs as snapshots to everybody else and they're going to see the same thing. But as we'll see, that magic can also carry some unexpected dangers. But when you built Tablix, you didn't just ship code. You built something people trust. You can see the growth. You have downloads climbing, usage spreading, and it feels really good to see adoption, to know that other people are relying on what you built. But that momentum is also what makes the next part worth caring about. The more people depend on it, the bigger the consequences if something breaks. Now, this is what the worst case looks like. You have big coverage, systems everywhere feeling it, and people waking up in the middle of the night. Imagine waking up to headlines like this. Your users are panicking, your customers are calling, your Slack and email are blowing up. Suddenly your wonderful growth story has turned into a firestorm. This is the moment every maintainer dreads. The good thing is, you'll probably never have something this massive. But even a small issue, something that affects a handful of your users, can be critical to the people depending on you. And even if it is small in scope, to you, it will feel huge. It will feel like everything is on fire because in that moment, your users are facing real consequences and they're looking at you. That's why how you respond matters. And then this is what it feels like. Everything you built is under a microscope. Get alerts, messages, issue pings, and people asking if you've seen it. Your brain is trying to split attention across 20 things at once. What now? Congratulations, you're officially the maintainer of a 0 day. That's not a title you've applied for, but hey, here we are. And in that moment, it can feel crushing. Your heart rate spikes, every GitHub star suddenly feels like a liability. And you start thinking, did I miss something obvious? Is everyone going to think I'm incompetent? That reaction is entirely normal. Every maintainer who has been here has felt that same stomach drop moment. The question isn't really if you panic, it's whether you freeze, hide the fix, or start moving with clarity. A quick intro, I'm Jonatan Männchen. I'm the CISO of the Erlang Ecosystem Foundation, and I co-run the CV numbering authority together with Ingela from the OTP team and Bram. And here's the roadmap, or what we're going to cover in the next half hour. First, assess. What is the problem? Is it public? And who does it impact? Then, shedding shame, because embarrassment derails any good disclosure. Next, coordinate the actual disclosure, bringing in the right partners and getting the appropriate advisory and identifiers. Then patch and release the fix, and finally communicate what happened. And for the next time, we should prepare so we know how to deal with those issues better if something happens in the future. The goal here is to take you from reacting in a panic and scrambling to acting with clarity. Okay, step 1, assess. Before we do anything else, we need to know what we're even dealing with. Is this a vulnerability? Is it already public? What's the impact and who is affected? If we skip this step, we're either going to overreact or underreact. The goal here is to get grounded before we start moving. So we're going to walk through this part very deliberately. First, is this even a vulnerability? That's the foundation of it all. We start by looking at what's actually happening. What is the behavior? Is it unexpected or unsafe? Then ask, can someone abuse this? Who would the attacker be and what could they gain out of it? A useful way to think about this is through the CIA triad. Does this affect confidentiality, integrity, or availability? That gives you language to describe impact instead of just hand-waving and making something up. For example, confidentiality might mean a Phoenix application that accidentally leaks secrets through an API. Or even something a lot more subtle, like debug logs printing API tokens into your logs. That's technically not a crash, but if somebody has access to your logs, they could impersonate a user with that. Integrity could be a bad access check in an API that would let one user tamper with another user's data. And availability? In Erlang and Elixir, we even have a classic for that, atom exhaustion. If an attacker can force your system to create new atoms unchecked, they can take down your node in seconds. Or it could be as mundane as an unbounded search query. A clever attacker can send a pathological input that ties up your database for seconds or even minutes, starving everybody else that is trying to use that same connection. Lastly, also consider scope. Is it something that would affect a single user, or could it ripple out to every deployment? If you're unsure where whatever you're currently looking at falls at, you don't have to guess alone. Reach out early to the Erlang Ecosystem Foundation CV numbering authority, and we can help you triage and figure out whether what you found truly qualifies as a vulnerability and how serious it is. Next up, is the vulnerability public? In other words, has anyone outside of your organization or team already posted about it? It could be an issue, a forum thread, a tweet, or anything like that, or worst case, even a proof of concept exploit. And much more importantly, do you have any signs that it is actively exploited somewhere out in the open? These questions matter because once the details are out in the wild, you can't control the narrative anymore. You may need to move into disclosure mode before you even start to write a patch. That means coordinating with the right channels and getting eyes on your advisory quickly, rather than quietly rolling out the fix days later. If it is private, you have a lot more breathing room and space to prepare, to draft your advisory, coordinate with the CV numbering authority, get a patch lined up. But if it's public, that exposure flips your timeline from days to hours. Time to verify. I crafted a little payload tuple pointing at OS command, wrapped in a base64 URL parameter, and dropped that into tablex's state. On the server side, tablex decodes it with binary to term, and then naively calls apply on it. And that's it, with remote code execution. In plain terms, if I send a query parameter state with some evil string, the server will run whatever system command we've embedded. So we've just confirmed tablex up to 1.3.7 is fully compromised. And just to be clear here, while this is a fictional library, this isn't unique. We have had very similar vulnerabilities in our ecosystem in the past. In this moment, we make 3 decisions. Yes, this is a real vulnerability. No, it is not public yet. It came to us via a private report. And our plan is to patch first and only publish the advisory once the fixed release is available. This approach gives us a little breathing room to craft a robust fix before anything goes public. So, Chapter 2, Shed shame. When you discover a vulnerability, your first instinct might be embarrassment or even guilt. You think, how could I let this slip? But trust me, everyone ships bugs. The real harm comes when we hide them instead of owning up and fixing them. Here's a universal truth. No one ships perfect code. Mistakes slip in your own code, or they just hitch a ride in your dependencies, often in ways upstream authors of these libraries never intended. A study of 14 million Maven releases showed that 63% of projects pulled in a known vulnerability through transitive dependencies. So if you feel that knot of shame, thinking I should not have introduced that bug, know that you are far from alone. Brené Brown defines shame as the fear of disconnection, the worry that if others really saw our mistake, we'd lose their trust. And that's exactly how it feels when a security flaw lands in our projects. But she also points out the only people who don't feel that shame are people who lack the capacity for empathy. So if you feel it, that's not a weakness, it's a sign that you care deeply about your users. When you find a vulnerability, your first instinct might be to hide it, to push a silent patch and hope nobody notices. But silent patches leave users unaware, scanners untriggered, and trust quietly erodes. And attackers do notice. Reverse engineering patches is trivial, so silence can actually hand them a head start. In fact, there are people and bots out there that do nothing but watch commit feeds and diff releases and look for suspicious changes. And if they spot the fix before your users do, the exploit window gets a lot longer instead of shorter. Worse, your community may feel betrayed if they find out later. Sometimes that even leads to forks, as people backport their own fixes. And without the proper advisory, automated tools like Dependabot or Mixaudit or Renovate will never alert your users to upgrade. They'll stay vulnerable long after your fix exists. Instead, owning the issue, publishing a clear advisory, explaining the impact, and crediting contributors builds confidence. For example, when a major framework in our own ecosystem recently transparently disclosed a security flaw, the community response was overwhelmingly positive, and the fix was adopted very quickly. And that's how you turn a mistake into an opportunity for trust. Chapter 3, Coordinating Disclosure. Now that we've assessed the issue and we've gotten rid of our shame, it's time to bring in trusted partners. People who know the ropes of advisories, CVEs, and responsible timelines. This is where we shift from a solo panic to structured teamwork. Let's pause and talk about CVEs themselves, because they're at the center of how vulnerability disclosure works nowadays. CVE stands for Common Vulnerabilities and Exposures. At its simplest, a CVE is a unique identifier, something like CVE-2025-12345. And it essentially says this security issue is the same ones these people over here are talking about. You can just think of it like an index card in a giant global library of vulnerabilities. Each CVE entry is a short and standardized record, with the ID, a brief description, and of the vulnerability, affected products or versions, and often a severity score, like CVSS. The point here is consistency. Every database and vendor can refer to the same issue in the same way. The CVE system itself is decentralized. It's run by MITRE, but managed day-to-day by a global network of organizations called CNAs, or CVE Numbering Authorities. CNAs are trusted partners that can validate and assign CVEs. There are CNAs for big vendors, like, for example, Microsoft or Red Hat, and there are ecosystem CNAs for specific languages and communities. The structure here matters because it means you don't have to wait for that single central authority. Instead, CNAs close to your ecosystem, or your company might have one, can handle reports, assign IDs, and ensure those vulnerabilities are captured quickly and consistently. So in short, a CVE is a common reference point. It doesn't necessarily tell the whole story of a vulnerability, but it ensures we're all speaking the same language when we describe one. Now, you don't have to navigate this whole process alone. The Erlang Ecosystem Foundation CNA is here from day one. If you're not sure whether what you're currently looking at is an actual vulnerability, just drop us a line at cna@erlef.org and we'll help you triage. Once you're ready, we'll not only assign the CVE, but we'll also help you draft your advisory, like wording, timing, and best practices, so that you don't have to reinvent everything from the ground up. And we'll stick with you through publication and any follow-up that you need. If your project lives on GitHub, you have a built-in security advisory system at your fingertips. This is, by the way, also what OTP is using. Users and researchers can safely and privately report vulnerabilities directly to your repository without opening any public issues. Behind the scenes, you can draft advisories in private, collaborate with your team and the CNA and the reporter, and then publish when you're actually ready. Once published, all advisories for your project are centrally listed on the Security tab, making it easy for your users to pick up on them. It's a quick and low-friction way to give your users confidence that you're on top of security. Once your advisory draft is ready, CNA steps in to validate information and also suggests improvements, like, for example, refining the CVSS score, which is a simple 0 to 10 measure that blends exploitability and impact. After that review, we obtain that CVE ID for you or any other CNA that you're working with. Very shortly, you'll get a message with the CVE ID that they reserved for you. That matters because once those CVEs are in the system, tools like Dependabot, OSV or open source vulnerabilities.dev, the US National Vulnerability Database or the new EU counterpart, and all the other databases that handle vulnerabilities can connect all the dots automatically. Without that CVE, you'd have scattered advisories with no real glue between them. Quite important here is, I mentioned reserving the CVE ID. Getting a reservation doesn't mean this whole thing goes public immediately. We just get you the ID, and once you're ready, we can publish the whole thing. So it is worth contacting the CNA early on in the process, and we'll wait until both sides are actually ready. Now that we know what a CVE is and how it is assigned, let's talk about how to actually read one. Every CVE contains a reference link, usually to a vendor advisory or a third-party advisory. That linked advisory is where you will typically find the most detail, like patch instructions, some context, and sometimes like a full write-up, like a blog post or something like that. You can look up any CVE on cve.org, which is MITRE's official site. And if it's an Erlang or an Elixir vulnerability, or at least a recent one, you can browse them directly at cna.erlef.org/CVEs. Each CVE has a standardized structure with a few common building blocks. We have the CWE, which is the type of weakness, something like improper input validation. We have CVSS, which is the severity score. We have a human-readable description. We have the affected list, which contains a list of products and versions that are impacted. There's workarounds and mitigations, which contain descriptions of short-term and long-term fixes. There's references, so links to advisories, to discussions around it, or anything else related to this vulnerability. And also credits to credit the researchers or reporters that found that vulnerability. Behind the scenes, all of this is published as a standardized JSON. That raw JSON often contains a lot more information than user interfaces show. So if you're analyzing a vulnerability, it can be worth just looking at the JSON directly to see if there's any additional detail. The key point here is the CVE is an ID, but attached to that ID is a structured record that gives you the who, what, and how of a vulnerability. and it always points you to the most authoritative advisory to get all the details of it. Now, I mentioned CVSS, or the Common Vulnerability Scoring System. CVSS is the tool that we use to boil a vulnerability down into a single number between 0 and 10. It works by scoring a few key dimensions: how the attack happens, so network or local, how complex it is, like do you need any special conditions, like a race condition that you can only trigger 1% of all the cases, what privileges the attacker needs, so do you need like an admin login to make this happen, or can just anybody do it, and what impact it has on confidentiality, integrity, and availability. Add all of those together and you get that one simple number. But there's a bit of a catch. That number will very often feel misleading to you. You'll see a bug with a score of 9.8 that in practice doesn't really feel catastrophic to you. And that's not really a mistake, that's how that system works. The number is just a shorthand, but if you want to gauge the actual severity and how this applies to you, you're going to have to look at the breakdown behind the number. For instance, imagine a denial of service that crashes your node reliably. It might score something like an 8.6, which sounds pretty catastrophic. But if you're behind a load balancer and you're running thousands of nodes, having one go down probably is not that catastrophic. But if it's the only one you're running, that's pretty bad. And so CVS captures the technical severity and not necessarily the business impact it has on you. For example, our TableX remote code execution. It is network exploitable, low complexity, no privileges, and full impact on confidentiality, integrity, and availability. That explains why it lands basically near a 10. It's at 9.3. It checks almost every box. But the real insight here is not just the number, it's the profile of how and why it is dangerous. Now, about the day after we got our private report and started drafting our advisory and also started working on a patch, proof of concept code hits Twitter. You see the tweet, somebody posted a gist demonstrating the exploit. Suddenly what was under embargo is out in the open, and it's getting traction. There's retweets, likes, and even some screenshots. That is the inflection point. What was a careful and private process now has public momentum. Your next move is no longer solely technical. You need to manage communication against the backdrop of public scrutiny. And just like that, we're also no longer on our own timeline. Public visibility sets the clock on your patch and disclosure. Every minute counts because attackers, scanners, and just curious onlookers are all watching. When it comes to disclosure timing, the key factor is where the details of the vulnerability are already out there. You don't need a full proof of concept. You just need public knowledge that people can exploit it, especially with today's automated tooling. If the vulnerability is public and you already have the patch, then just go ahead and publish both the advisory and the fix immediately. If it's public but your patch is not ready, you still must disclose now and provide interim mitigations so that your users aren't caught off guard. If the vulnerability isn't public and your patch is ready, or take the time, prepare, and release all that in a timely fashion. But we really want to be sure that we're avoiding two extremes, rushing without a plan or delaying when our users need answers now. Chapter 4, Patch and Release. Now we've coordinated the disclosure and it's time to write the actual fix, retire the vulnerable versions, and push our patched release. When you start coding your fix, do it in private. Don't just push it to a public branch where people might see your commit or CI logs might expose what you're doing. Do it in private. GitHub security advisories support private forks for exactly this reason. In our example, switching to a safe decoding API, specifically for TableX, we'd use plug crypto non-executable binary to term with the safe option, which blocks any dangerous term formats. Also, in our case, we should probably rethink our payload design, encoding modules and functions is probably not the best idea. We should probably just encode data instead, so we also don't have any call sites for arbitrary code. And finally, bake in tests. Test your new logic well, so to make sure that no edge cases slip through. With the patch coded and tested, step 1 is to publish your fixed release. Bump the version, tag it, push to hex, just as you always do. Also consider which versions your users are currently using. So if you just recently released a new major version and 2/3 of your user base are stuck on an old major version, you probably want to fix both and not just the newer one to ensure that your users can remediate that issue quickly. Next, tell the CNA that it's now time to publish the CVE now that your patch is available. This officially injects that identifier into those global vulnerability feeds. And then also flip your private GitHub security advisory, or if you handle it somewhere else, from draft to public so that the world sees your advisory alongside the code. Finally, retire the affected hex releases to prevent any new installs of the vulnerable code. Now, retiring a version on hex does 3 key things. First, new installs will automatically avoid any retired releases. Second, users who still have a locked retired version get a warning if they run mixsteps-get or the rebar counterpart. And I guess the same for Gleam. And on hex.pm, the UI will very clearly label retired versions with your retirement message. You should retire each vulnerable release with the appropriate hex command and a concise reason describing why you're retiring this version. So put the actual CVE ID in there so people can find it. That ensures that no one inadvertently pulls in the broken code once that is known. Now, Chapter 5, communicate. Your fix is out, the advisory is live, and the registry is up to date. But that does not mean everybody knows. Next, we'll cover on how to broadcast the news to ensure that your users actually see it. Once your advisory and patch are live, your top priority is ensuring that your users know exactly what happened and how to upgrade. A clear blog post or release notes should distinctly describe the vulnerability, its impact, and the exact commands to update. Next, you should probably amplify that message in social channels and on ecosystem forums so that it appears where maintainers and users frequent. And finally, you probably also want to add a prominent note to your project README or changelog so that anybody browsing the repository immediately sees that there's a security update. Once you publish your advisory and the CNA publishes the CVE, that metadata doesn't just sit in place there. It ripples outward. Your GitHub security advisory and CVE entries will automatically feed into mitracve.org, the US National Vulnerability Database, the Open Source Vulnerabilities Database, the GitHub Advisories Database, and 1,000 of these more. In turn, there's a lot of tools like the OSV Scanner, Dependabot security updates, Mix Audit, Paraxial does this as well, and all of these tools, they watch those feeds, and they will flag users of the old version, and in many cases even open automatic upgrade PRs for them. That automated wave ensures that your fix reaches every environment where it's needed, and not just the ones you directly control. Finally, let's talk about preparation. We've just weathered a storm, and now it's time to shore up our defenses so that the next incident is less of a panic and more of a practiced drill. A security.md file is your playbook for when trouble strikes. It should first list an email and link directly to your GitHub security advisories if you support that, so that reporters have a direct channel to report vulnerabilities privately to you. Next, you should specify supported versions, so which releases you'll provide patches for, so that your users know if they're in scope or out of scope when they're using your software. Next, also specify, did that already. List your contacts and roles, including the CNA and your core maintainers, so that we ensure the reports land in the right inbox. Also help by setting clear expectations around response and resolution. You don't need exact service level agreements or anything like that, but you should indicate generally what reporters can expect in terms of acknowledgement and follow-up. Finally, I recommend including a PGP key as well, or a fingerprint, so that sensitive details can also be sent via insecure channels like email, if people don't want to use your advisory tool. With these sections in place, you'll be ready next time and you don't have to scramble to figure out on who does what. The next important point is automation. First, you can use Dependabot security updates, so it opens pull requests for whenever any of your dependencies ship a new security patch. And if you're not on GitHub, RenovateBot is a really cool tool which offers the same kind of thing, just across a lot of different platforms. If you're on Elixir, the mixed dependency submission action extracts your Elixir project's dependencies and submits them to GitHub. That unlocks some advanced features like a complete dependency graph, alerts for direct and transitive dependencies, and even a pull request review tool for overall better visibility into your dependencies. There's also the OSV scanner, which can be used to run directly against your log file to compare it with all the reports on osv.dev. And Mix Audit can be used for Elixir-specific scanning, surfacing CVEs right in your CI. Together, all these tools form a safety net, alerting you early so that you can fix before the next incident. In a corporate setting, you can augment these community best practices with organizational muscle. First, you should really maintain an accurate software bill of materials using standards like CycloneDX. And there's tools that use these SBOMs, and you can combine them with vulnerability feeds, and you're alerted the moment a flaw appears. Where if you just run it in your CI, you're only going to ever find out if you do a change. Next, don't treat open source as a black box. Build relationships with the teams behind the libraries you use. Sponsor their work, help triage issues, or even simply just share how you're using their projects. Those connections will pay dividends when a vulnerability crops up. Also consider sponsoring the Erlang Ecosystem Foundation and your critical dependencies to keep the CNA and other security efforts funded and the libraries you depend on maintained. Finally, bake all these checks into your software development lifecycle. Automated scans, security gates, etc. ensure that no release slips through unchecked. Let's wrap up with 4 key takeaways. First, prepare by setting up a security policy for all your open source projects. If you only take one single thing from this talk, please let it be this one, because when an incident comes, having a clear process already in place will make everything else survivable. Second, ground your response. Methodically assess severity, scope, and visibility before every move to avoid over or underreacting. Third, own the narrative. Get rid of your shame, coordinate open disclosure, and leverage the CNA partnership to build user trust. Fourth, retire and publish. Use hex retirement to block old versions, publish your advisories, and ship patched releases. And remember, if you do nothing else, having a security policy today means you're already better prepared than most projects out there. None of us ship perfect code, but all of us can ship with integrity. The next time you find yourself staring at that gut drop moment, remember, you're not alone, there's a process, and there's people like the CNA ready to help. Preparing today means when panic comes tomorrow, you already know how to turn it into clarity. And that's how we go from freakout to fix. I want to take a quick moment also to thank the sponsors of the Aegis initiative. Without their support, this work and this talk wouldn't be possible. With that, I'd love to hear your thoughts and questions. Thank you.
Questions? It was a pretty good talk. I had a lot of things I was thinking about, but formulating a question's hard. But maybe one option would be if I needed to proactively do anything in my projects to be better prepared for these sorts of incidents. What sort of things can I do? Not just after it happens, but before.
So if you're in an end user project, like, I don't know, your company's SaaS service or something like that, the most important part is to actually scan for these vulnerabilities. If you have a library, however, I think the most important part is that security policy. Because if you are at the point where people are basically only left with the choice of opening a public issue or posting in the forum or something like that, they will expose your vulnerability to everybody. And you're going to be very much on the clock fixing this. But if you have a clear security policy and people know how to reach out to you, then you have a much better chance of being able to resolve the situation in a calm way.
Thank you. Another question?
I know there's this distributions mailing list where a lot of important people are in, receive information more early than. At which point does it come in?
It depends a bit. These distribution mailing lists are mainly for like Linux distributions and stuff like that. So if your project is actually one that is distributed with Linux, some package manager, it absolutely makes sense to post on these. We're doing that regularly for the OTP vulnerabilities if we disclose those. However, if you, I don't know, wrote an Ash extension or something like that, you're probably not going to be on there, so basically that will just be noise. So you always have to figure out where is the place that where your users are actually looking to, and try to publish all this information in these kind of forums where it makes more sense.
But it will be done by you, basically. If the library is also in a Linux distribution, it will be done by the EF.
I mean, so far we only had to do that with OTP, and we did that in coordination with them. If you have a library that falls into this category, I'm sure this is something that comes up. Who writes the message in the end is not the important part, I guess. I'll happily send an email for any project out there for disclosing their vulnerability, for sure.
Thank you. So I have a question. As a library author who is also vendoring some of the dependencies, are there ways of getting the nice feedback from tools like Dependabot and so on, but for vendor dependencies, which made it a lot harder since they're not like dependencies that can be scanned directly?
Right now, I don't think so. Probably the best way you could do it is if you wrote an SBOM in whatever way, and there's tools to submit an SBOM, for example, for Dependabot, and then it would at least know that something is wrong. I don't think it could update it, but it would at least tell you about it. The corporate way to do this is to have SBOMs and submit them every time you do a change, and then basically submit them to a tool like Dependency Track, or there's others like Guac and various other tools. And you can also at the same time hook them up to vulnerability feeds, and if it finds a match, you can configure what it does, like send a Slack message or send an email or something like that.
All right. Thank you again.
Thank you.